Hello mathematicians, puzzlers, and other curious people. So I've got a bit of a follow-up today. If you haven't already taken a look at the blog post from a few days ago where I asked you to come up with a list of numbers, but not just any numbers, by following a particular procedure. So I asked you to pick a number. I picked 573, just at random. Took the keypad on my keyboard and kind of squished my fingers across it. And then add one, and then instead subtract one. So then you've got three numbers, 573 in my example, 574, and 572. Then the thing I asked you to do was add up those three numbers. So I'm going to get us a way to write down what we got from that now, and we're going to look for some patterns in it. So let me just switch slides. Here we go. Okay, so we started with 573. Okay, so then what we did is we said 573 plus one more plus one less. And by my calculations, that came out to 1,719. So I asked you to come up with several numbers like this. So let's see. If we select 25, we would then have 25 plus 24 plus 26. Oh, I got those out of order, but it doesn't matter. They'll add up the same. And so we'll get 75. If we select 3, let's see, 3, one more is 4, one less is 2. 3 and 4 and 2 make 9. If we have 67 and 68 and 66, that will give us 201. So as you can see, we can take any number, one more and one less, add them together, and we'll get some number that we've got in these lists here. So I asked you to look at patterns in this list. So what kind of numbers show up here? One thing I notice is that they're all odd. So then I thought about that for a minute and I said, wait, maybe that's because all of these I'm not going to explain exactly what these words mean. I know some of you haven't studied this yet, but I'm going to call these my domain and these my range. So I noticed that what we started with, our domain, was all a bunch of odd numbers. So I said, okay, let's test that pattern and see what happens if we use an even number, like 10. So let's see, 10, one more would be 11, one less would be 9. 10, 21 gives us 30. Okay, so that's even. So it's not the case that this way of generating numbers only gives us odd numbers, because we can get an even number out of it. It might be the case, so I'm going to jot this down as a conjecture, that odd numbers give odd numbers and even numbers give even numbers. Now I want to point out we haven't written a proof for that conjecture. It's just an idea, a pattern that we might have noticed. Now I noticed something else though particular about these numbers in our range. I noticed 30 is a multiple of 3 and 9 is a multiple of 3. I also noticed 75 is a multiple of 3. If that one didn't pop into your head, think about how many cents in 3/4 of a dollar. Also, if you are up on your divisibility rules, 2 and 1 add up to 3. So 201 is a multiple of 3. Also, let's see, 1 and 7 and 1 are 9, 9 and 9 is 18, 1 and 8 is 9. So 1719 is also a multiple of 3. So this seems to be giving us a bunch of multiples of 3. But that also is just a conjecture. We're just guessing that it's what might be going on here. Now, conjectures are different from things we know for sure. It's just a pattern that we've noticed. When we have a conjecture, we usually try to prove it somehow. Now, if there were only so many numbers, we could try just making an organized list. So like 1, well, let's see, 1 and 2 and 0 gives 3. That's a multiple of 3. 2, well, let's see, 2 and 3 and 1. 5 and 1 is 6. That's a multiple of 3. Now the problem with doing it this way is we'd be at 1,000,000, and that would give us 1,000,000 and 1,000,001 and 999,999. Whoops, I shouldn't have put a comma there. Easy to fix though. That's the nice thing about whiteboards. It's all erasable. Mathematicians love whiteboards because mathematicians make millions of mistakes. Being a good mathematician does not consist of avoiding mistakes. It consists of fixing them, or getting your friend to fix them. So then we would have, well, spoilers, 3,000,000. Go ahead and do the column addition if you want to verify that, which is a multiple of 3, but we're still not done because we've only checked 1,000,000 numbers, and that's not even close to infinity. So the method of making an organized list and checking everything is not going to work for this problem. It's a good idea to gather evidence to see if it's worth trying to get a full proof, but it's not a proof itself. So one thing we can do instead is use formulas. So I'm just going to say n is going to be the name of a number. I'm just going to give it a name. So like we started with 573 up here, so n is going to be that same, it's going to be just a stand-in for the number we start with. So n will map to the sum of itself, one more, and one less. Okay, so then just a little bit of algebra here. I notice that if we have n plus n plus n, that's going to be 3 times n. Let me check off the terms I've used. Okay, well 1 minus 1, that's 0. So 3n and 0 is what we have here. Well, 3n and 0 is really just 3n. So this number pattern gives us 3 times the number we started with. We can check that also just to make sure we didn't make any mistakes in our algebra. I'm grabbing my calculator real quick. So let's see. 573 times 3 is 1,719, just like we have right here. 25 times 3 we know is 75 from cents and 3/4. 3 times 3 is 9 because we know it's a basic multiplication fact. 67 times 3, that's a good calculator problem, and I get 201. 10 times 3 is 30. Okay, so it looks like not only does this make sense in the formulas, but it works. So whatever number we plug in, our output will be 3 times that number, which is definitely a multiple of 3. I'm going to do a little bit of mathematical symbol use here. So for all values of n that are natural numbers, which is what we were naturally using here. If you were using some crazy fractions or decimals, your result might be different from mine, and that is okay. That's just a matter of our domain here. All the numbers I picked in my domain were some subset of the natural numbers. And the natural numbers are ones we often use for problems like this when we're looking for number patterns, because they do such cool things. Okay, so now I'm going to wrap this up pretty quick, but I am going to leave this question on the board. Not that one, sorry. This conjecture right here about odd going to odd and even going to even. So I'm going to come back to this in a little while longer, but feel free to see what you can come up with in the meantime. If there's any reason you can find a formula for why that would have to be true. But we've seen that this particular way of generating a list of numbers gives us all multiples of 3. Now feel free to look for anything else that's true about it, or any other patterns based on what kind of number you start with. So I'm Avrila at Math with Avrila, and I'm going to say for now, calc you later.